What's that? Yeah, to get the ellipse, we cut the cone at a fairly sharp diagonal, and that gave us an ellipse.
Not all the way down to the bottom.
No, because if you end up going down through the bottom, then you get something called a hyperbola.
Yeah.
How would you draw an ellipse? It has a major and a minor axis. What's the major axis? So an ellipse is kind of like a squashed circle. So the major axis is the longer diameter, and the minor axis is the shorter diameter. Okay. What else do you know? All right, so what you have, I'm going to make an ellipse for you. Here's how you make an ellipse. You take a piece of string and you fix 2 points. These 2 points are called the vertices. I'm going to hold those 2 down. And then you take your pen and you keep the string tight. Oops, and you go around like so. And then the hard part's going to the other side. I gotta go through my fingers here. I might not be able to do that. Anyway, that gives you the top half of an ellipse. So, you have these 2 fixed points. What are these 2 fixed points called? Not vertices. The vertices are out here. These are called the foci. Correct. So for an ellipse, I'll just draw freehand the bottom half. It won't look as good. It was good for a while. All right, so in here, we had 2 fixed points. These are called the foci. Not focuses. They're used in drafting, correct. And the rule was, notice I held the string tight all the time. So if I pick a point here, and I measure this distance, and I add that distance, it's always the same. Because I was holding these 2 points, and I stretched the string out. So if I was holding the string here, I had the same total length as when I slid it around here. I still had the same total length. I mean, this length would be shorter, but this length would be longer. But if I added them together, this length plus this length would be exactly the same as that one plus that one. And that's the definition of an ellipse. The definition of an ellipse is you have 2 foci. If you take any point, the sum of the distances from the point to the foci is always the same. All right, and then we already called, this is called a vertex, as is this point over here. We also have a point right in the middle. What do you call the point right in the middle? Not focus. Not directrix. Midpoint's close. Give you a hint, it's right in the center. So we call it center. This is called center. Yeah. Sometimes, I ask easy questions and I make them sound like they're going to be hard. This distance here, this line going through the foci, going from vertex to vertex, this is called the major axis. Axis. This distance from the center to a vertex, that length, that's typically called A. Then if we go from the center and we go up and we go down, we get 2 more points. These are called covertex. Or together they're called covertices. And if we draw the line straight up and down, we already used these words. This line is called the minor axis. And the distance from the center to a covertex is called, well, the distance from the vertex to the center was A, then the distance from the covertex to the center is B. That's right. And finally, the last letter we have is the distance from the center to a focus. Well, A, B, what's left? Alright, so we have lots and lots of terminology, and lots of words, lots of symbols, lots of distances involved with the ellipse. Alright, now comes the equations. We're going to, again, make our life pretty easy. We're going to draw our ellipses so that the center is always at the origin. Makes things slightly easier. If you have an ellipse like this, which is long but not very tall, then the equation is x squared over a squared plus y squared over b squared equals 1. Where, what's A again? Center to vertex, all the way out. So A is from here to there. That one's A. A equals distance from center to vertex. And what's B? Close. Not vertex to covertex, rather center to covertex. We measure everything from the center. So B goes from here to there. That one is B. So B is distance from center to covertex. And then there's a little formula that we use. C squared equals A squared minus B squared. So it's almost that old familiar Pythagorean theorem that we're used to, except it's got a minus in the middle. Normally you would use that equation to find the missing side in a triangle. That's correct. What we're going to use it for here is to find the missing distance. So I know A and B. What I don't know is C, but I can use that equation to find C. And what does C tell me again? Distance from center to focus. Alright, so that's one kind of ellipse that we'll look at. We'll write down some equations here in a minute and we'll work it out. So, sometimes we have ellipses that are like that. Sometimes they're long but not very tall. What other kind of ellipses might we have? Tall but skinny. Alright. So if we have one that's tall but skinny, not a whole lot changes. One like this still. Our center is still going to be at the origin. The only thing that really changes is this one has x squared over b squared plus y squared over a squared equals 1. So what's different? The major and the minor axes change, which means the bigger number, the A, goes under the y squared. A is always going to be the bigger of the two numbers because A is always the distance of the major axis. Well, half the distance of the major axis. So, You can tell which way an ellipse goes by looking at the numbers. If the big number is under the x, then x has the major axis. So if the big number is under the x, the ellipse is long but not very tall. When the big number is under the y, the ellipse is tall but not very wide. And everything else is exactly the same. A is still the distance from the center to the vertex. It's just that now the vertex is up here. B is still the distance from the center to the co-vertex. The only difference is the co-vertex is now over there. And C will still fit this equation. C squared equals A squared minus B squared. And C is still the distance from the center to a focus. And the foci will be inside like that, whereas in this one they were inside that way. Okay, so here's what a typical problem might look like. I might give you x squared over 25 plus y squared over 4 equals 1. And I'm going to ask you for the following information. I'm going to ask you to give me the vertices, give me the co-vertices, give me the foci, what about the B? It's flying around. And finally, we'll draw a graph. So B's nice. Why not? Looking at that equation, is this ellipse long but not very tall? Or is this equation tall but not very wide? Long but not tall. How do you know it's long but not tall? Well, the A value is always bigger than the B value. The big number is under the X. When the big number is under the X, that tells you it's long. When the big number is under the Y, that tells you it's tall. Okay. So, what is the A number? The A number is 5 because remember in our equation this has A squared down on bottom. Our A number is 5. What's the B number? 2. Okay, I'm going to start drawing a graph while I'm answering this. Do it all at once here. Where are the vertices? How far left and right? Not 5 squared, not 25. That's too far. Negative 5 and 5. So I start at the center, which is at the origin. The vertices are going to be here at 5, 0. A is 5, so I go 5 to the right, and 5 to the left. Negative 5, 0. So there's our vertices. 5, 0, negative 5, 0. Where are the co-vertices? Which direction? Up and down. So I really shouldn't call it 2. I should really call it 0, 2. It's a point. And this one would be 0, negative 2. There's our co-vertices. Well, from that, I can draw the picture. Oh, that looks like a line too much. Oh, well. You do your best, you know. It's never going to look great, but you do your best. The only thing we haven't found is we haven't found the foci. To find the foci, we need to find the C value. How do we find the C value? Plug it into the formula. C squared equals A squared minus B squared. A squared is 25, B squared is 4. So C squared is 21, which means C is square root of 21. Okay. So where are my foci? That's correct. Where inside of that? plus or minus square root of 21, am I going up, down, left, or right, or diagonal? Left and right. Why left and right? Because it has to be on the major axis. So our foci are somewhere around there. And this one's at square root of 21 comma 0. And this one's at negative square root of 21 comma 0. So there's all the information. There's our vertices, our co-vertices, and our foci. Questions on that? All right. What if I give you this one? How about x squared plus y squared over 9 equals 1? Is this one? Well, first off, how do we know it's an ellipse? The other day we were saying when we had x squared and we had y squared, we had a circle. How come this one's an ellipse and not a circle? What's the difference between an equation of a circle and an equation of an ellipse? Not the one. That must be the other thing. The only other thing left is the 9. Must be the 9. If I wrote x squared over 9 plus y squared over 9 equals 1, that one would be a circle. Right. So the difference between a circle and an ellipse, for a circle, the numbers in front of or underneath the x squared and the y squared have to be exactly the same. A's and B's have to be equal, which means your major axis and your minor axis are the same length, so then you get a circle. Correct. So this one would be a circle. Of course, I could take this whole thing and multiply it by 9. We would probably usually write it as x squared plus y squared equals 9. That one would be a circle. You can tell this one's an ellipse because it has the x squared, but it's got y squared over 9. It doesn't have the same numbers in front. That's the difference between an ellipse and a circle. All right, so this ellipse that we have, is it long but not very tall? Or is it tall but skinny? Tall but very skinny. How do you know it's tall but very skinny? Okay, so what number is underneath the x?
1.
Yeah, if there's no number there, then we think of it as being a 1 underneath. So, the bigger number is under the y. Since the bigger number is under the y, that tells us it's tall. So our A is not 9. A squared is 9, which means A is 3. Remember, that's always A squared down on bottom right there. B squared is 1, which means B is 1. And as long as we're here, I guess we might as well figure out C. C squared is A squared minus B squared. That's going to be 9 minus 1, which is 8. So C is the square root of 8. Alright, so drawing my picture. Where do the vertices live? The vertices are at 0, 3 and 0, negative 3 because the A number is 3 and this one's going up and down. This one's tall. Sometimes we get lazy and we write vertices this way, 0, comma, plus or minus 3. Instead of writing two of them, we get a little lazy and we write it that way. So if you want to be a little lazy and write it that way, you can. How about the co-vertices? Close. 0, 1 would be right here. I don't think you mean right here.
Oh, 1, 0.
1, 0, yeah. 1, comma 0, and negative 1, comma 0, because our B number was 1. So again, I'm going to be lazy and write that as plus and minus 1, comma 0. I can draw my ellipse. That looks pretty good for me. All right, how about the foci? Where do those babies live? Correct. They're up and down this time because our ellipse is up and down. So there's 0 plus and minus square root of 8. Questions on that? All right, so that's the first kind of problem you're going to see. I will give you an equation, and from the equation, you will give me information. The other kind of problem you're going to see is I'll give you information, and you give me the equation. For example, I might say, center at the origin, vertex at 0, 7, co-vertex at 3, 0. From that little bit of information, you should be able to tell me the equation. To do that, we first have to decide, is this ellipse long but not very tall? Or is it tall but skinny? How do you know it's tall but skinny? Because the y is the 7 where the x is the 3. The y is the bigger one. That's right. So this one's going up 7, but only to the right 3. So this one's tall and skinny. That tells me it looks like x squared over b squared plus y squared over a squared equals 1. And I think really without doing any work, I know the a and the b. What's a? A squared is 49 because a is 7. And what's b? B is 3, so b squared is 9. Yeah, this is one all you got to do is decide that it's long, tall, and skinny and plug the numbers in. Answer is x squared over 9 plus y squared over 49 equals 1. Questions on that one? Center is still going to be at the origin. Vertex is going to be, I don't know, anybody have a number they like? 5, 0. And a foci is at, let's say, 3, 0. I'll give you a vertex and a foci. I guess it would be a focus. I only gave you one. Focus. One of the focus. And I would have to say one of the foci. A focus is at 3, 0. All right, well, so once again, I think we need to ask the question, is this one long but not very tall? Or is it tall but skinny? Long and tall? Long but not tall. Long but not tall. How did you decide this was long but not tall? Well, think about what they said here. If you're thinking of a picture, they said the focus is at 5, 0, which is there. Oh, I'm sorry. I'm sorry. The vertex is at 5, 0, And the vertex is always the longer one, isn't it? The co-vertex is always shorter. So this one has to look like this. The vertex has to be the long one. So yeah, that one has to be long, but not very tall. And the foci is in here, 3, 0. Okay, so since I know the vertex is at 5, 0, I know one of the numbers that I need. Let's see, x squared over, this one's going to have a squared, plus y squared over b squared equals 1. Do I know the a number or the b number? Which one do I know? I know the a number. The a number is? You got it backward. A is just the number 5. This number is 5, so that's the a number. So a squared is 25. So a is 5, we know that. Do we know the b number? If we did, we'd be done. That'd be nice. I don't think we know the b number. But I think we know the c number. Yeah, I think we got to put it in the equation. What's the c number? C is 3, because C comes from the focus. So C has to be 3. So here's one where we have to use C squared equals A squared minus B squared. That means 3 squared, which is 9, is going to equal 25 minus B squared. Get the B squared all by itself. Subtract 25. 9 minus 25 is negative 16 equals negative b squared. So b squared is 16, which tells me b is 4. The truth is I really don't need to know b, I really need to know b squared. Because in my equation I really want a b squared right there. So quite often with these b won't come out to be a nice number. But that's alright, we just need b squared anyway, and b squared will come out to be a nice number. Final answer looks like x squared over 25 plus y squared over 16 equals 1. Questions on that?